So, this is actually, I made a mistake. I got to change the week thing. Okay, start with the Duna. Okay, remember we discussed tide. Okay, now I give you two pictures, tide versus wave. What's the difference? You get more about waves here. You got waves with wind directions here. One wave, okay, we call it wind waves, okay, just because of the wind. And swirl waves is different. It's actually because of the um, energy from the ocean surface, not because of the wind. You can have that kind of surface with or without wind. So what would be the difference between tides and wave? Anyone, please?
Tides is caused by gravitation of moon and sun.
Very good. Yes, sir.
Waves is caused by the winds.
Oh.
Sometimes can cause by earthquake as well.
Very good. Okay, thank you, sir. In this case, do we have waves during the tide times? If there's a tide, do you think we can also see waves as well?
Yes.
Yes. So tides can involve waves, okay? Because there can be wind at any time, or the movement of the surface under the ocean. Okay, so tides can involve waves, but waves can it be the other way around? Can waves will be because of tide? Yes or no?
Can you say it again, teacher?
Okay, I said tides will have waves. Everyone agree?
Yes.
Okay, so that means if there's the tide, there are waves.
Yes.
Right?
Yes.
Can we go the other way around? That means if there are waves, we can say it is because of the tide.
No. No.
No. It can be without, you can have waves without tide. Waves actually happening all the time because of wind or the energy from the ocean surface, not because of tide. Tide happens only because of what?
Gravitational.
Gravitational, because of the position of sun and earth and the moon, isn't it? Are they perpendicular or are they straight line? And we have tides. But winds can be at any time. Doesn't matter where the moon is, doesn't matter where the sun is, doesn't matter as long as the earth is rotating, we have the waves. Yes, Gugu, what's your question?
I want to know that people do surfing in the wave. People can also do stuff in the tides.
Oh, that's a good question. The answer is no. Okay, because the tide, when we actually look at tide also depends on the time of the day. Okay, it can be only evening and the early morning, sometimes midnight. Okay, so remember we talk about the position of the moons. If the moon is closest to the earth, it can be midnight. Okay, we don't do surf at certain time, right? When we do go for surfing, you're not going to wait for midnight, or you're not going to go very early in the morning, right? So for surfing, basically surfer will check the weather reports, when will be the strongest wind. So they follow that. Okay, right. Okay, so now we actually look at the difference between tide and wave. Especially if you are in America, you have to know about this Gulf Stream. It is very, very important, and I'm going to explain it. So what we're going to discuss today, waves are usually caused by wind, although sometimes waves are caused by earthquakes. Remember, we'd already discussed it. So basically, because of the earthquakes, we're going to call the waves tsunamis. Now, like I said, in America, this Gulf Stream is very important, okay? It's caused by the very big system of circular movement, circular currents, and powerful winds. So circular current means we're talking about the current in water. I don't want you to be mixed up between electric currents and ocean currents, okay? Current is actually anything that flowing is called a current. Okay, not stopping. Flowing is a current. Now, electric current is the flow of electrons. Okay, a flow of electrons. But now when we say current in ocean, we're talking about flow of water. Water is flowing. Now here, that water flow or the current is actually circular way, and then it's actually caused by the wind as well. That Gulf Stream is very important because it actually, we're going to do it when we do Earth and Space again. I'm just giving you the introduction. It's actually transporting not only the warm and the cool water, also nutrients from the bottom of the ocean as well. So it's very important for the aquatic system there. Now, when you actually look at the direction here, you can actually see the currents actually going from the one side of the equator to the another part. That means the water temperature will be different. So warm water will actually go in to do that the top, and cold water sink in, and then it's actually making a circular way. And another thing is it's because of the very strong wind. Like I said, when we do Earth and Space, we're going to look at wind as well. Okay, the wind is actually because of the rotation of the Earth. The Earth is rotating. Remember, we discussed that. Okay, so that rotation is one of the reasons we got wind. We're going to discuss it as well. Okay, so now what we actually discussed is the difference between tides and waves. We all know that the tides are just because of the gravity of the sun and the moon, but tides are also waves. Okay, in this case, we're going to look at the characteristics of waves. What are waves? Okay, waves carry energy, therefore all forms of energy are carried by waves, and we can see all the waves. It's actually 3 parts. Consider the following statement and discuss. Wave carry energy is 1 point. Therefore, all forms of energy are carried by waves, and we can see all the waves. Can anyone tell me what you think about the statement? Let's say, first of all, do you think the statement is true for each part? Or do you think one part is true, not every part is true, or all parts of the statement's wrong?
I think we can see all of the waves.
We can or we cannot?
We cannot see.
We cannot? So, okay. So you're saying we can see all of that. Last part is wrong. Okay. All right. What do you think about the first 2 parts, everyone?
Like
Of the
Yeah.
you go first, Heather.
yeah, you go first.
Okay, Simon.
I think all forms of energy are carried by waves are false.
Okay. All right. Okay. All forms of energy. Okay, that's right. Okay. So what about the first part?
I think yes.
Yes. Okay, very good. Waves carry energy, but not all forms of energy are carried by wave. For example, if it is a chemical energy, would it be carried by wave?
No.
No. But Xylem said that all parts, we cannot see all parts of the waves either. So what we're going to look at is the characteristics of waves, type of waves. Okay. Now, identifying the wave in the pictures provided. What kind of wave we talking about? Here.
Sound wave.
Sound wave. Very good. Does it carry any energy?
Yes, sound
Yeah,
energy.
sound
Yes.
energy. Sound
Very
energy.
good. Very good. Kinetic energy. Okay. Can we see the wave?
No.
No.
No, we cannot see the wave. Okay, sound wave. It's actually carrying kinetic energy, but we don't see it. We can hear it because of the vibration. What is next one?
Microwave.
Microwave.
Microwave. Can we see it?
No.
Yes.
Can you see microwave? Who got the?
Yes.
Who's the superwoman,
Yes, we can
superhuman
see
here?
Yes, we can see the microwave.
You can see the microwave, huh?
It's the
When do you see the
microwave, not the microphone.
I think these are like the thing, the whole thing, microwave.
Microwave?
Not the
Are you
things,
talking
like the waves.
about the microwave as a device or a heat energy that is inside of the microwave?
Okay, now you actually given me the clue as well. I'm not talking about the device. We're using microwave in there, but you use heat energy. It is the energy transformation. Okay, but can you see the microwave? You turn the plug in and you press the button. You might see the light. It is light. It is not microwave. Okay, the light is actually the signal your microwave is working. Right? And you get the heat energy. What we want to do, we want to heat up the food in the microwave. So can you see the microwave?
No.
No, you don't. Okay. What you've seen is the visible light in the microwave. That's what we're going to discuss when we discuss the electromagnetic wave. Okay. What about this one? That's an easy one. Have you ever heard of Mexican wave? Mexican wave, especially in the sport event.
Yes.
No.
Yes, Mexican wave means one person stand up here and sit down, another person next to the group stand up and sit down, things like that's called Mexican wave. Okay, so the picture is about Mexican wave. So can you see the Mexican wave?
Yes.
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 Does it carry any energy? That's a tricky one.
Ye-
Yes.
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 Not really in a physical form. Okay, because every group is using their own kinetic energy, not actually from, but they got the image, they got the message in the brain, and they said, oh, I'm going to stand up, I'm going to sit down. Okay, so they're using their kinetic energy and potential energy, but not transferred from the next from the adjacent group. Does that make sense?
Yes.
That's a tricky one. Don't worry. Okay, another one. When you actually wave the flag, do you see the flags actually moving in that way?
Yes.
Can you see it?
Yes.
Yes. Does it have any energy?
Yes, I think.
Yes, from your hand to this. So connected energy transferred. What about this one?
Electromagnetic.
Electromagnetic wave. What that guy looking at it?
X-ray.
X-ray. Good. Does it carry energy?
Yes.
Yes, it must. Can you see it?
No.
No. Okay, let's have a look at the last one. Very easy one. This one. What are we looking at?
Wait.
Wave energy.
Wave.
Water waves. Does it carry energy?
Yes.
Yes. Can you see it?
Yes.
Yes.
Yes. And now we can actually, from the photos, we already look at the different types of waves. Some waves we cannot see. Some waves we can. But we all agree all the waves carry energy. Yes or no? That's why we're going to look at the type of waves. Okay, these forms of energy, as said, I use it over and over again, so everyone should know it by heart now. We're talking about connected and potential energy. Okay, here waves cannot carry the chemical energy or gravitational. I don't want to say that now because people are scientists are talking about gravitational waves, so I'm going to leave it out, but it is still in a very infant state, so we don't have any particular confirmation yet. But definitely potential energy cannot be carried by waves. All the connected energy here, okay, light energy, sound, almost all of it, okay. Magnetic is actually in gravitational, so I'll put it there. So light, sound, thermal, mechanical energy, they are all connected energy, and they can be carried by waves. We already discussed two types of waves. The first one, remember the water waves? Water waves here, or the waves in the flag, or wave in the string. They are all called mechanical waves. Okay? The other waves we cannot see, like light, X-ray, microwave, they are all called electromagnetic waves. Doesn't matter, waves carry energy. Okay, now what would be the difference? So what is actually the source of energy? for this one, for example, we are talking about water waves. To get the water waves, first of all, imagine you have a little bowl of water, okay? And the water is stationary. If you want to make wave, you can actually make wave in that water by doing what? Dipping your finger, move your finger, isn't it? So you got a little wave. Okay. Right. In this case, what is the source of energy?
I did.
Your connected energy from your fingers, okay? So basically, waves are actually the disturbance in the medium. Now, when I say medium, what medium I'm talking about here?
Water medium.
Water.
Water. It can happen in air as well, yes or no? Yes,
Yes.
air has
Yes.
particles as well, so air is a medium as well. So waves are actually the disturbance in the medium, okay? Usually that disturbance is the energy, source of energy. Here, the source of energy is your finger, your connected energy transfer from your fingers, okay? What happened? Those energy will be transferred from one particle to another particle to another particle. That's why we call waves carry energy. Okay? Everyone understand? So waves are actually energy carrier, and there is always a source. For mechanical waves, it must be a mechanical disturbance, but it needs a medium. Okay, if we are talking about water wave, the medium is water. If we are talking about the waves in like sound waves, the medium is the air. If we are talking about earthquake waves, the medium is the lithosphere. Understand? Good. Then electromagnetic waves, completely different. Okay, they don't need a medium. The source is the vibrating charged particles, not the connected energy from any mechanical source. Okay, so electromagnetic waves, again, they carry energy, a lot of energy, okay, but they don't need any media. They can go through the vacuum. That's why we got light from the sun. Okay, the lights from the stars. Remember, we haven't started up the solar system, but we got the atmosphere to the certain altitude. After that, there is no air, okay, vacuum, but we still get the light because it can travel through vacuum. We're going to discuss how it happens later. But so far, I'd like you to understand two different types of waves, mechanicals and electromagnetic. And the differences, similarities and differences. Similarities, both actually carry energy. Differences, mechanical wave require medium, electromagnetic wave doesn't. Any question? Any question? Okay, now here, yes, Gugu.
I have a question.
Mm-hmm.
I'm not clear about the microwave. I think then that device named microwave, is there actually a wave called micro like that?
Yes, that's where we're going to look at next lesson. Microwave is part of the electromagnetic wave. Okay, so when we actually look at electromagnetic spectrum, you understand all of it. Not only microwave, we're going to look at radio wave. We're going to look at light, microwave, X-ray, gamma. We're going to look at all electromagnetic spectrum. Okay.
Okay.
Okay. So now we all agree waves carry energy. So I give you the little visual here. One thing I'd like you to understand is when waves actually carry energy, they just transfer the energy, not the particles. For example, if the particle is here, the particle will move up and down because of the energy from the wave, but the particle doesn't move from here to there. Does it make sense? So waves carry energy, not the particles. Particles are in the medium to transfer waves. When I say medium, I'm definitely talking about mechanical waves. Okay? So we are going to look at the characteristics of waves. Okay. Now, today I'm going to talk about mechanical waves. Okay. Now, when we say mechanical waves, we know that it's actually there must be a source. The source is going to be the mechanically transmitting or transferring energy. Okay, even though we're talking about mechanical waves, the properties or the characteristics of waves are the same for electromagnetic wave and the mechanical waves. For example, have you ever heard of wavelength, frequency, period? Put your hand up if you heard those terms. Have you ever heard of wavelength? Very good. Frequency, period, amplitude, very good. Okay, in this case, you will, I think it a lot easier for you to understand that. If you did not hear any terms before, please pay attention, please. Okay, now we talk about mechanical, we're going to start talking about mechanical waves. Like I said, it needs a medium. That means it has to go through a solid, liquid, or gas. Without solid, liquid, or gas, mechanical waves cannot go through. Remember, we already said that. Can you hear sound in space?
No.
No, because
No.
there is no particles in space. That's why astronaut got to use radio wave, and they got to carry that receiver and transmitter to communicate with each other. You cannot, if you are yelling in space, no one will come and help you. So another thing is like sci-fi movies, you will see a loud explosion in space. If there's that explosion in space, can we hear it?
No.
Never. We will not hear it. We will see it, but we will not hear it. Okay, so this is about the mechanical waves. Now, I've been trying to look for this little spring or the slinkies. I cannot. I just want to show you the demonstration. Can anyone visualize the spring here? Okay, we can actually make two different types of waves in the slinky or the spring. You attach the spring to one end. You pull it here. See that direction of the pull? Okay, and if you actually, and before you actually do anything, you holding some loops of the spring here. Can everyone see it? Okay, you can try it if you can find the slinky or the spring. Sometimes you will find plastic slinkies as toys for kids. Okay, so you hold some loops in your hand, and then you let go only one loop. Okay, only one loop. What would happen? You holding like say so many loops in your hand and you let go of only one loop. What would happen to the rest of the spring here?
It will shrink.
Sorry, what would happen?
They will shrink. Loop will shrink.
Shrink, what do you mean shrink?
Like-
Like go, how should I say?
Oh, I think I
Gonna
need to
vibrate.
vibrate. When they vibrate, which way they vibrate? Back and forth or up and down?
Back and forth.
Back and forth.
and
Let's say
forth.
you let go one loop here. So it will vibrate. So that vibration will be transferred to what? The next one. Yes or no?
Yes.
So if you actually watch it carefully, that vibration is actually transferred from this end to this end, and then it will come back. Okay, that's why I really want to do the demonstration, but I can. In this case, we are actually causing the disturbance in the medium. The medium here is what?
Hi.
The medium here is what?
Air.
Not air, because we
s-
actually
the
can see it
spring.
here. If it is air, we cannot see it. What are
The
we talking about?
spring.
The spring, the
Spring.
loops of the spring. That's a medium, isn't it? And you actually transferring your connected energy from your hand here, and that connected energy will be transferred from this one end to the other end. And now we see a form of wave here. The direction is going towards this end, coming back. So the direction of waves is actually what? Parallel to the movement of those springs. The springs are moving back and forth. The waves is going this way and that way. So the direction of the movement of the loops and the direction of the wave going back and forth, are they parallel or are they perpendicular?
Parallel.
Parallel.
They are parallel. Okay, they're going this way and that way. Now, imagine you change the way of the movement of your hand. This time, you holding the loops, but you're going to move your hand and down. Okay? In this case, the movement of the spring will be what? Up and down, going from this end to that end. But then again, if you actually use slow motion, you say it is coming back this direction. In this case, the direction of wave is from left to right. But the particle movements, the particles in the medium movement, or the loops here, they moving what? Left or right, or up and down?
Up and
Up
down.
and down.
Up and down.
Up and
In
down.
this case, the direction of wave and the particles movement, or the particles in the medium movement, are perpendicular. Can you see the difference? And then based on those properties, we can actually classify the waves in longitudinal and transverse wave. Longitudinal is the one, okay? Remember, I was actually talking about the first one. Longitudinal is the direction of the wave, and the particles in the medium's movement, they are parallel. Okay, it is longitudinal. Transverse is the direction of wave and the particle in the medium movement are perpendicular. It is called a transverse. So we're going to classify the waves into longitudinal and transverse. I already describe it. Okay, for example, when we actually look at the spring, okay, when you let go one of it, you will see the movement of the particles and the direction of wave. But the transverse is actually the perpendicular. Okay, so when you actually look at it, this is the longitudinal waves. Okay, and second one, you can actually see some earthquake waves are transverse wave. So we classify two as the, what am I doing? Right, now let's classify some waves. Mexican wave, is that longitudinal or transverse?
Transverse.
Transverse.
Transverse, very good. All right. So this is again, when you say the direction of wave is from one end to another, but the people moving up and down. That's why we call it transverse. Now, I have another homework today. This time, I'd like you to think about the, let's go back to our scientific method. You will be doing an experiment this time. Last one wasn't an experiment. Last one was just, you can call it experiment, but related. But this one is definitely the experiment. Which cups make the best telephone? Have you ever tried that? Have you ever played that one? When you were young, you used two
Yeah.
cups, and then you actually use a string, okay? And then one actually whisper from one into one cup, and you try to figure out what the other person is actually saying from the other end. Right. You are going to, this is the question, which cups make the best telephone? So you will need different types of cups: paper cup, tin cup, plastic cup, foam cup. Okay. Now, what you're going to do is you will be, one thing though, to do the experiment, you have to do it at home. That means you might need someone to test your phone at home, because your group work, you cannot be physically together. But I don't know, Heather and Xylem, you might be doing your experiment when you see each other. So you're just joking, don't worry. So you need to actually think about someone who's actually holding your phone from the other end and talking. Right. You are going to write the experiment report. Your experiment report should have aim, equipment, method, independent, dependent variable, and control variable as well here. Okay, how variables are controlled to treat it as a fairly, and your results and your conclusion. Now, when I say results, would that results will be qualitative or quantitative?
Qualitative.
Qualitative, because if you want to measure, yes, you can, but you cannot, because you need some equipment to measure the loudness of the sounds. We use decibel, but you don't have it, so don't worry. So your results will be qualitative, like, oh, I can hear well, I can hear, okay, I can hear the sound very softly or loud. So that would be only qualitative. Now, your aim should start with 2. For example, yeah, what are we talking about? Which cups make the best telephones? Now, in telephones here, what energy do we want to hear from this end?
Sound.
Energy.
Sound.
Sound
Sound
energy. Okay, sound energy or connected energy. So what are we changing here?
Caps.
Cups. Okay, I can actually give you another idea. If you cannot find different cups, but we can, if you can find different strings, you can change the strings instead of cups. Depends on what's available to you. You can actually change either strings or cups. As long as you identify your variables correctly, I don't have any problem. Okay, so that investigation, the aim is what? To observe which material transmit the sound energy better. That's an example. Okay, so you are going to observe, or you're going to investigate which material, which medium sound actually travels better. So that's going to be the aim. Start with 2. Here, equipment, like I said, you will actually need the equipment according to your availability. And method is a procedure, step by step, 1, 2, 3. We don't need I do it or she do it. Just write it as a command. Okay, for example, get 2 different cups or get 2 strings. Yes, son, what's your question?
Teacher, if we choose to change the cans of cups, we have to choose how many cans? Like 2 cans?
Two cups for one kind. For example, 2 paper cups and 2 foam cups.
Oh, yes.
Because you need 2 cups for each material, both
Yeah.
ends, right? So you got to think that way. So method should be written in a procedure, 1, 2, 3. Now, the main thing is I'd like you to identify independent variable, dependent variable, and controlled variables. Okay? Then you will be actually recording your results in a table, and it should be that there should be conclusion. So and this time, instead of the presentation, I'd like you to email it to me, okay? So I can actually mark and give you the feedback via email as well. So it will be due on, let's say, Tuesday, okay? Tuesday, 20, today is 26. No, it is going to be in February, right? Now it's 26. So it will be, I think, 6, no, Thursday. What would be the date? What would be the date?
30.
Yeah, today is 25th.
Today is 25th.
Yes.
No, today. Oh, I am looking in March. Oh my God.
Oh,
I'm not looking
wait.
at January.
Today is 25th.
Today is correct. Today is 25th. Oh, then
So
Tuesday is 30th.
first,
Okay.
first 30. Wait.
No, next week, Tuesday is 30th. 30th of January, isn't it?
Yes.
So due date is 30th of
Oh.
January. You can do it during weekend or start tomorrow, and send me email or messages if you have any question. Everyone's okay with that? Yes, Heather?
Sure. Is it a group work or individual?
Oh, it is a group work. That's a good question. Thank you. It is a group work, but like I said, you're going to test your experiment with someone at home, because you got to actually do it with someone at home. But when you plan the method, reports and conclusion, it can be a group work. So you can actually swap your results with each other. But you have to agree with your group members what independent, dependent, and control variables are. It should be uniform amongst the members. Does it make sense?
Yes.
Yes.
If you cannot find a group, you can do it on your own. Okay. That means like, okay, I got someone to help me at home to listen, to basically to listen from the other end. You need another person to help you to do that, right? But if you can do it on your own by recording everything, you don't need a group. Can be either individual or group work. It's up to you. I'm not going to put too much pressure on you on that one. Any question?
No, teacher.
Very good. So this is about what kind of energy we're talking about? What energy are we talking about
Sound energy.
for your experiment?
Sound energy.
Sound energy.
Sound energy. Very good. And sound energy, is that the mechanical or electromagnetic?
Mechanical.
Mechanical.
Mechanical. So it will need what? To travel?
Medium.
What would it need? A
Medium.
medium. What medium are you using? Are you using solid, liquid, or gas?
Solid. Solid.
Gas.
Solid.
Gas. You got the string made of gas or what?
Solid.
Solid. The sound from this one end will actually go through what? Go through the string. So we actually looking at the mechanical energy and the medium is the string. Okay? So that's what I like you to understand and I like you to do it. Now, we're going to move on to the important part. We're going to look at those properties or the characteristics of waves: speed, frequency, wavelength, amplitude, crest, and trough. I'd like you to take a screenshot for this one, because when you actually look at the other columns, you see physical. What does it look like? You might not see what does it look like for speed or frequency, but you will be in a minute. Behavior. Okay, why is it important? And why is it what other interesting ideas do you have about speed, frequency, wavelength, amplitude, and crest and trough? So I will actually go through the next slides, but I will actually let you do that in your group later. Any question? Everyone got a screenshot? Okay, right. So what we're going to do is here, get another screenshot, label a wave. First of all, I'd like you to tell me whether it is a transverse or a longitudinal wave.
Transfer.
Transverse. Why?
Because it's moving up and down.
It's being
Very good.
perpendicular.
Particles are moving up and down, but the wave is actually in perpendicular. Right. I'm going to explain that whole thing from here. Remember, when we actually look at a water wave, we will see the top part of the wave. That top part of the waves are called crest. Okay? And if there's a top part, there is a bottom part as well. The bottom part will be called troughs. Okay, we got crests and troughs. Everyone understand? This is something you can see easily. Okay, right. Once you understand that, we're going to actually look at other terminology as well. Wavelength means from here, look at the wave here, going this way, the direction of wave is here. Wavelength is the distance between two crests, two adjacent crests, or two adjacent trough, or the whole complete cycle from here to here. Okay, so depending on the diagram you have, you can actually identify the wavelength on the diagram by looking at the crest and their trough. Okay, that's why I told you crest and trough first. So if you want to know the wavelength, the top, the adjacent distance between two crests, two troughs, or the complete wave. Now, we are going to call, this is a one complete cycle. This is also a wavelength. We are going to call amplitude. the distance, okay, the distance of the maximum movement, maximum displacement of the wave. That means how high is the crest or how deep is the trough. It is called amplitude. Okay, don't make a whole distance between crest and troughs as an amplitude. No, it is either the height of the crest or the depth of the troughs. It is called amplitude. Everyone understand?
Yes.
Yes.
Okay. Now we got the wavelength, we got crest, troughs, and the amplitude. We're going to look at frequency. Frequency means what? When we say, oh, I do it frequently, what do you mean by that?
Again and again.
Again and again, or how often, isn't it? How often you do is a frequency. That means frequency in wave means how many wavelengths going through a point in 1 second is called frequency. Does it make sense? Okay, how many waves going through? That means how often you do it. Very similar, isn't it? So how many wavelengths passing through one point in 1 second is called a frequency. In this case, we're going to find period as well. Period is time, isn't it? So in wave, period is how long it takes to take one complete cycle or one wavelength. Okay, so for example, here, let's say this is one wavelength here. If it takes 2 seconds for the waves to transfer the energy in a complete cycle, the period is going to be 2 seconds. Okay, and period and the frequency are reciprocal. Okay, reciprocal means F equal 1 over T. T equal 1 over F. Right. So now, here, this is what I explained. Wavelength, okay, can be different. Amplitude is actually here the height of the crest or the deep depth of the trough. They measured in meters. We're talking about SI unit. Another thing is that are the symbols. When we say wavelength, you will see little upside down Y. Do you see upside down Y and Y here? That's a Greek letters called lambda. So wavelength, the symbol is lambda. Frequency, the symbol will be F. Period is going to be T. Okay, because period is a time. So we're going to look at and the unit. Frequency, we know that per second, but per second, it got a new name called hertz. Okay, so hertz is actually named after the scientists. Okay, so it's actually the number of cycles that pass at a given point per second. And the last one is speed. Have we learned speed in Newton's law? Yes or no?
Yes.
Yes.
Yes. What is the formula for speed? Anyone recall?
S by T.
S over T. Here, speed is going to be the same formula, distance over time. We're going to call distance what? Wavelength for the speed. Okay, we're talking about waves. So the distance traveled by a wave is going to be called wavelength. Okay, so wavelength over T. Remember, period and frequency are reciprocal. So 1 over T is going to be what? 1 over T is frequency. Isn't it? We're talking about reciprocal. That's why for wave, the speed formula will become V equals F lambda. F is the frequency of the wave, lambda is the wavelength. Or V equal lambda over T, same thing. Any question? Everyone okay? So far?
Yes.
Okay. In this case, we're going to move on. Take the screenshot because you're going to do the calculation in your breakout room. So take the frequency. Sorry, take the screenshot for calculation. So basically, this is about substituting the formula. Okay, right. Now, another screenshot. This time, like I said, you will be doing it in a group. So to check your understanding, because I really need to move on. But you need more information for this one. Remember, we actually use transverse wave to look at the crest and troughs and wavelength. Remember? Now, we're going to look at longitudinal wave because in the very first example about the slinky, remember I said in the spring, to see the longitudinal waves, you have to let go one loop and it will actually transfer the vibration to the other end, right? In longitudinal wave, you will not see crest and trough and wavelength in this position because the particles will be moving. Which way? Parallel or perpendicular?
Paula.
Parallel. In this case, you have to understand how we're going to define wavelength and crest and troughs. Instead of crest and troughs, we're going to call them compression and rarefactions. Okay? I might actually try to get the slinky and I show you next lesson, but I'm not sure. But in a longitudinal waves, if you actually do that, let go one or two loops, it will go one way and then coming back. Some area you will see the loops are very close to each other. Some area the loops are further apart. Okay, so in this case, when the loops are very close to each other, loops are the particles. When they're close to each other, we're going to call it compression because they compressed. Okay, and next to the compression, the particles will be further apart, and then we're going to call them rarefactions. So instead of crest and trough, you will see compression and rarefactions in longitudinal wave. Okay, then how are we going to measure the amplitude in the longitudinal wave? Okay, in longitudinal wave, it is going to be the displacements between one compression and one rarefaction. Okay, so that the formula will be different. No, sorry, formula is not going to be different. The terminology will be different. Instead of crest and trough, you will be using the compression and rarefaction, and the formula is going to be the same thing. Okay, now, take the screenshot for this one as well, so you can actually do the questions as well. Right, how many screenshots you got so far? Are you counting?
I think it's like 4.
4. Okay, can you take this one 5 as well, please? All right, in this case, I'd like you to, but the very first one, this one, I'd like you to do it as homework because this is actually about thinking, and some of you might find it that physical behavior and so what hard, so you can actually take your time. Don't worry about this one. Okay, so this is your homework, and I'd like you to do this one, this one, this one. Did you get this one as well? Okay. Right. So will you be able to do it in your group? I can open the, let's see, what time is it now? 10 o'clock. Let's see, I give you 15 minutes, okay? Try as much as you can.
Can you go back to the picture with the man running? Do we have to also take that picture?
Which one?
Previous one,
This one?
not that. No,
That one?
yeah, this one. Do you also need this
No,
one?
no, no. This one, we already do it as a group, so don't worry.
Oh, okay.
Okay, the rooms are open.
We don't know how to measure the wavelength or the
Hmm.
amplitude.
I don't know how to measure the amplitude.
Okay. Which one? Which page?
Wave
Uh,
1, wave 2.
The
Okay.
wave
Oh, wave
one, the
two,
wave 1, wave 2, wave 3. Yeah, the last
Ah,
part. I think.
okay. Right. Let me So you are talking about this one?
Yes, teacher.
Yes.
Yeah, yes,
Okay.
yes.
That's right. You cannot do it on the screen, of course. Okay, so let's do it hypothetically. All right. So if
Okay.
depends on your the size of the photos. How many we can don't worry about the wavelength and amplitude. Okay, we can come back to that, but you still can do frequency. If we don't know the wavelength, we cannot do speed. So let's start with frequency. Right? Now hang on, you cannot because there is no time given, isn't it? Wavelength, amplitude, frequency, speed per.
We can just
Okay.
use the time as 1 second for the whole photo, maybe.
Okay, we can do frequency for that one. Can we?
Yes.
Yes.
Okay.
Yes.
What's the frequency of this one?
5.
5.
5.
Good. So we can get
5.
frequency 5 hertz. Okay. We can do that one. Now, just use the screen. Okay. What would be the amplitude? Just approximate.
1
We just-
centimeter. Yeah.
1 centimeter, 2 centimeter,
1.
1.
Just 1.
1 centimeter. Okay, good. 1 centimeter. We got amplitude 1 centimeter. What wavelength?
2 centimeter.
2 centimeter. So in this case, you
Maybe
just
2.
need to agree with your group members because, like I said, if you actually making the big image, then the measurement will be different. But we all can agree on frequency 5. Okay, we can actually get speed here if we can agree on wavelength. Wavelength is 2, frequency is what? 5,
5.
and the speed will be
10.
Yes.
10 centimeter per second. That's how you're going to do it. Okay, because we discussed, if it's not on paper, we cannot use paper and pencil. But the idea is, do you know how to measure or calculate the properties of characteristics of waves? Do you know what is amplitude? How are you going to measure wavelength? How can you calculate the frequency from the diagram? That's all you need to know. Yes or no?
Yes. Yes.
Okay. In this case, let's do the other questions as well. Right. This one is very easy, isn't it? Question 1 and 2. Room 1. Did you calculate the answers for those 2 questions? Room 1,
Yes,
April, Google. Yep. Can anyone call out your answer, please?
For
Yes,
now, it's
teacher.
2 meter
Yeah.
per
Two.
second.
2 meter per second.
Mm-hmm.
Number 2
Okay,
is
and
330
very
meter
good.
per second.
Very good. Okay, so that's an easy one. Room 2. Do you have answer for this? Question 1?
Yes.
Chell, Heather, Sun, or Uziel, anyone. Number 1, wave motion that is parallel to the wave direction described as a
Longitudinal.
longitudinal. Very good. Room 3, Nancy, Simon, Wei, or Xylem, anyone. 2, something is a maximum upwards displacement of a transverse wave.
Crest.
A crest. Very good. Room 3, Nancy's, oh no. Oh, did I? Okay. Room 4, Mimi, Pri, or Victor. One complete wave cycle is referred to as a
Wavelength.
wavelength. Very good. Come back to room 1. Wave motion that is perpendicular to the wave direction described as a easy one. Room 1.
Transverse wave.
Transverse wave. Okay. Something or something is the maximum displacement in a longitudinal wave. Room 2, please.
Compression
A compression or rarefaction is a maximum displacement. And an ocean wave would be an example of what, room 3?
Transverse wave. Transverse.
Transverse wave. Very good. And 7, the distance from one trough to another trough is called a room 4.
Wavelength.
Wavelength again. The measurement of displacement is called a wave's what?
amplitude.
Amplitude. Okay, so do we understand all of those? That's the main thing. Okay.
Yes.
This is an easy one, right? Did you finish this one?
Yes.
That's child's place for Burmese students. We Burmese are very good in maths, right? Asians are good in maths, not like white people in Western countries, okay? They can do 100 by 20 without a calculator. Believe me, I saw it, okay? Now, number one, a wave has a wavelength of 12 meters and a frequency of 10 hertz. What is the velocity? Any volunteer, please, from any room.
120
Thank you. Unit?
meter per second.
Meter per second. Thank you, Victor. A wave has a wavelength of 3 meters and frequency of 15 hertz. What is its velocity? Anyone?
45
45
second.
unit?
meter
Meter
per
per
second.
second.
Meter per second. So I'm going to skip 3 and 4 because it's so easy, right? Okay, right. We already did that one. Okay, so we did that one as well. And I think that this is okay. Let's do this one. What is the wavelength of a sound wave with a frequency 50 hertz? Speed of sound is 342 meter per second. Anyone got any answer?
6.84
Thank you. Unit?
meter.
Meter. Okay. Now, I'd like you to do question 2 because we can discuss something from here. A sound wave in steel rail has the frequency of 620 hertz and the wavelength 10.5 meter. What is the speed?
6,500.
1510.
Very good. Now, I'd like you to compare the answer for question 1 and 2. Question 1, the speed of sound is 342 meter per second, right? And question 2, you calculated. It's at the speed of sound is 600 and something, right? Why are they different?
600. Because
Why are they
they
different?
are traveling in a different medium.
Different medium. Very good, Salman. Different medium. So in question 2, what medium are we talking about? Solid, liquid, or gas?
Solid.
Solid.
And what do you think about question 1?
Air.
Air or gas. So which medium sound wave travels faster?
Solid.
Solid.
Solid. Why?
Because of vibration.
Because the particle are so high.
Someone said something
Yeah.
about particles. Can that person speak up again, please? What happened to the particles?
The particle.
In solid, particles are what? Packed closely. In this case, the energy transfer is more efficient, right? And I don't know if you actually watch some movies, probably the Western movies. Sometimes actually you might see this in some people actually try to listen, put their ears on the ground, right? Why do they do that?
Because they want to hear the sound.
They
or
want to
the
hear from
vibration.
the enemies or someone approaching. Before they hear it in the air, they can hear it in the earth's crust. Does it make sense?
Yes.
Okay, so sound travels a lot faster in solid than in gas. What do you think about water? What would be the speed of sound in water? Just a guess. I am not asking you the numbers.
Faster than the air.
Faster than the N and slower than in
Solid.
solid. Okay, so that's how particles arrangement in solid, liquid, and gas can be related to the speed of sound in solid, liquid, and gas. Okay, even in gas, if we are talking about the speed of sound in gas, it depends on the temperature. Okay, why? Just focus on gas. Do you think the sound will actually travel with the same speed on a hot day and the cold day?
No.
No. Which day the sound will travel faster? Hot day or the cold day?
Hot day.
Will be faster.
Cold day.
Put your
Cold
hand
day.
up if you say hot day. Good. Cold days. Oh, you think I was just raising okay. What would happen to the particles in a hot day? Would they be closer or would they be further apart?
Farther
Further
apart.
apart.
Farther
Further
apart.
apart. In this case, would sound be traveling faster in a hot day?
Oh.
No.
No. So cold day, you will hear the sound faster, okay? Than the cold day. Okay, so we already look at the characteristics of the waves today. Those characteristics are the same. We use the same wavelength, amplitude, frequency for either transverse or longitudinal waves. And we focused on what wave? Mechanical or electromagnetic wave?
Mechanical.
Mechanical. So what are we going to do next lesson?
Electromagnetic.
We're going to
Electromagnetic.
look at electromagnetic waves. Okay, any question? Okay, don't forget your weekend homework. Have fun with your little phone, okay? Play with your phone and make sure you actually submit your homework as well, okay?